I got some beeps. Here we go. Welcome, ladies and gentlemen. So, we were looking at page 5, safety safe, as I said earlier, and we were simplifying rational expressions. We were multiplying, we were dividing. And the trick to this one, well, let's see. First, I'm going to simplify some stuff here. 9x squared y cubed over, I'm going to distribute this square to all of these, 25x squared y squared z squared, as perhaps our English friends might say it. And I'm going to change this to multiplication, where I'm going to multiply by the reciprocal of this. So now 20x squared y is in the numerator, and the denominator is this guy. 3 cubed is 27, x cubed, y cubed. All right, so that was my first switcheroo. I did the old reciprocate and change it to multiplication. There is what I did. All right, and now I've got a whole lot of simplifying to do. Let's see, 5 goes into 20 4 times and into 25 5 times. 9 goes into 9 once and into 27 thrice. X squared and x squared cancel out here. This y squared cancels out y to the third, leaving 1. This x squared cancels out with this x to the third, leaving 1. And this y cancels out with this y to the third, leaving 2. And there's other canceling that I can do, but I'm going to wait until I combine stuff a little bit first. So let's see. So I've got x to the first. No, that's a y to the first, isn't it? I think that was the y to the first, yeah. Y to the first. There's a 4 up here. There's no x's up top just yet. Let's see, my denominator, I've got 5 times 3 is 15. It's a little tricky to follow all this canceling work. I've got x, y squared, z squared, I believe, so far. And then, looks like one more simplification I can do, where I could cancel out this y with one of those, leaving 1. So I believe my answer is 4 over 15xy z squared. Let's see, any verification? We are correct. Whew. Nice. So we got the first one done. One and done. So how about some other preguntas? Otros preguntas para mí de su tarea de anoche. Okay, I like them. Let's see. Yeah, I'll do 35 for starters. Then maybe we'll fit one more. Good stuff. Paste. So yeah, most of this is going to be just our factoring skills being our potential limitations. So let's see. Let's factor everything. Let's see. This numerator, I could steal a 6 from. So I would have 6 times x. Nope. 2x plus 1. This denominator, this is going to have a couple things going on in it. I could steal a 21 from both of those. And then I'll actually be able to do something else after that. X squared minus 1 would be what's left. I'm going to change this to multiplication and multiply by the recip. So my denominator is my new numerator. This will be 7x squared that I could steal from there. So that's now in my numerator. So I'll have 7x squared times, that would be x minus 1, I believe. And, I could steal a 3 from all of those. Still isn't going to have me avoid the AC method, sadly. But we tried. 3 times 2x squared plus 3x plus 1. So, there are 2 more things I can still factor, to factor completely. One of them is this guy right here. What can I do with that? Yep. So let's see. I'm just going to duplicate this real quick. Blah, 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 blah. And this up top is the same, 7x squared x minus 1. That doesn't look anything like minus 1. There we go. And we'll have 3 times, and I think we'll end up with 2 sets of parentheses here. Well, actually, I'm technically not certain that's factorable yet. So I'm going to do some little scratch work on the side. So 2x squared plus 3x plus 1. I would AC method that. That's 2. The factors of 2 are 1 and 2. Which of those add to be 3? The only factors we have. So I do split the b term, 2x squared. That'll look like a lambda right there for a minute. Little Half-Life reference, lambda squared. Let's see, then we'd have split into, I'll do 2x and 1x plus 1. It looks like both of these signs are going to be plus plus, right? So I split the b term into 2 like terms, who were the factors we just found, right? Whose coefficients were the factors we just found, rather. Let's see. Yoink, yoink, I could steal a 2x from these, and we'll have x plus 1. And I could steal a 1 from those, so plus 1 times x plus 1. So it looks like it did factor, where I'll have x plus 1 and 2x plus 1. Alright, so half the battle, or most of the battle actually, is just trying to factor everything. And now that it's all factored, we can really go Fruit Ninja on this. Let's cancel some stuff. Let's see, 3 goes into 6 twice. 7 goes into 7 once, and into 21 3 times. What else cancels here, folks? Yep, those x minus 1s. And the 2x plus 1, and the 2x plus 1. So let's see what we get. So in the numerator, I've got 2 times x squared is 2x squared. Over, in the denominator, I've got 3 times x plus 1 times x plus 1. Right, that is x plus 1 squared. So those don't cancel out because they're on the same level, right? And I believe that's everything I've got. And it seems to verify with the answer up top. So yeah, that was a lot of factoring. A lot. No doubt. Yawn, yawn, yawn. Here we go. Let's do one more problem. What's our preference? 33 over 37? Yeah. Alright. We can do. And this will be the last one for the homework. Zoom it in. So here we are. So let's see. I'm going to do a little less of my factoring arrows and such. The top I could factor 3 out of and get x squared minus 1, and hopefully you recognize x squared minus 1 very well. Denominator I could factor a 2 out of, so 2 times x squared plus 8x plus, 4x plus 3. I'm now multiplying by the recip. How could I factor this denominator, my new numerator? My numerator, am I right? A GCF, steal a 4 out of that. And my old numerator, my new denominator, looks like I could steal a 5 out of that. Although, nope, we got to steal a 5 out of it. And then I think it might actually be a pattern. Oh yeah, that's a pattern. It's funny, as I went to like a math convention conference course last fall, and some math teachers wrote their X's like this, like where they would write like this piece and then this piece. And I thought that was so weird. Like, isn't that weird? It's a weird way to write an X. Do like that, right? And then there's another person that wrote them even I don't know. I can't even think. How do you write X's so different? I don't get it. There's only one way to write an X, people. So let's see. Let's factor a little further. What's this guy? Yep. Hopefully you guys are getting really good at spotting those patterns. 2 times. This one's a little quick factor. Factors of 3 are 1 and 3. They add to 4. So what's that going to factor to be? Yeah. Multiplied by 4 times x plus trace over 5 times, and this one's a pattern. It's going to be some parentheses squared, but even if you didn't notice the pattern, you could write it as 2 separate things. Does anyone know how to factor that? It's a perfect square trinomial. X minus 1 all squared. Right, so that matched the pattern a squared minus 2ab plus b squared is equal to a minus b all squared. That's the pattern that we used to use all the time when we were completing the square. Right. So, Fruit Ninja time. Swipe, swipe. Here we go. 2 goes into 2 once, into 4 twice. Then I've got x plus 1, x plus 1, x plus 3, x plus 3, x minus 1 with one of those x minus 1s, leaving just one behind. So yeah, you can see the benefit of having multiple colors. So let's see, 3 times 2 up top is 6 over 5 times x minus 1, is it? Looks like that's all that's left over. Yeah, verified right up there. If the book is right and I'm right, probability suggests chances are we might be good. So, there's the homework. Goodbye, Internet.